Hello students, I am Nilanjana Sanyal, an online math tutor from India. Welcome you all to my channel NS Online Math Classes. Now as you know, we are learning the chapter on the Binomial Theorem, and if you have watched my videos, you should be knowing, and of course I'll be asking you to watch my videos sequentially. You will be seeing that I am taking up every topic covered in a particular chapter so that you do not face any difficulty while trying to solve the past paper questions. By saying the past paper questions, I mean the IGCSE Maths, the Additional Maths, the IBDP, that is IB Math, AA and AI, and the AS and A-level Maths. Okay? And in case you are having any doubt, any question, please feel free to write to me in the comment area. Also, please share your feedback on the videos so that I get motivated and I know how are you feeling about these videos. Okay? So now, in our today's session, we will be finding the coefficient of a term where the power of x is given, and there will be two binomial expansions multiplied together, and we will be having x in both the binomial expansions. Okay, so let us start with our today's session. Now the first question of this session says, find the coefficient of x to the power of negative 2 in the expansion of x plus 1 to the power of 3 times 1 over x minus 2x whole raised to the power of 6. As I had said in my previous session, also we had seen there were two binomial expansions which were getting multiplied together. But in that case, we had seen that x was present in one of the terms. Both the binomial expansions contained x, but x was present in one of the terms. And I had said in this session we will be taking up questions where we will be having x in both the terms. Of course, for the first binomial expansion, we are not having x in both the terms, but for the second one, we are seeing that x is present in both the terms. And in the next question, the second question of our session, we will be seeing that we will be having two binomial expansions multiplied together, and over there, each binomial expansion will be having x in both the terms. Okay, so now let us start with this question's answer. Since this binomial expansion contains x in both the terms, let us take up this first. Okay, we may take this, but this is very easy to expand, so I am taking up the second one first. Okay, so 1 over x minus 2x raised to the power of 6. As I had said in our previous session that just get the powers of x. Write the powers of x term by term. Don't have to write the signs, don't have to write the coefficients, just get the powers of x for each term. Okay? We will be doing exactly the same thing for this session questions as well. Okay. So we start with the first term. The first term will be 1 over x raised to the power of 6. I am repeating, I am not writing the coefficients. So 1 over x raised to the power of 6. Second term, it is 1 over x raised to the power of 5. Times x raised to the power of 1. I am not taking the minus 2 part, only the x. Third term, 1 over x raised to the power of 4 times x square. Next, 1 over x raised to the power of 3 x cubed. Next one, 1 over x raised to the power of 2 x to the power of 4. 1 over x times x to the power of 5 and finally x to the power of 6. These are the 7 terms, excluding the coefficients of course and the signs. Now we just simplify them to get the powers of x because that is what we need. So 1 over x to the power of 6, then it is 1 over x to the power of 5 and in the numerator you are having x. So 1 over x to the power of 4. Next, x to the power of 4 in the denominator, x square in the numerator. So it is 1 over x square. This one, x cube in the denominator, x square in the numerator. So it is a constant term. This x square in the denominator, x to the power of 4 in the numerator. So x square. This one, x to the power of 1 in the denominator, x to the power of 5 in the numerator, hence x to the power of 4 and the final one, the last term will be having x to the power of 6. Okay. Now we come to the first part because this one is very easy. So it is x to the power of 3, x to the power of 2, x to the power of 1 and finally 1. And they are asking us to give the coefficient of x to the power of negative 2 or 1 over x square. Okay. X to the power of negative 2 is equal to 1 over x square. So which two terms will get multiplied to give us the term containing 1 over x square or x to the power of negative? If we start with this 1 over x to the power of 6, so x to the power of 6 is in the denominator and we have to get x to the power of negative 2 or 1 over x to the power of 2. So with what should it get multiplied to give us the power of x to the power of negative 2 or 1 over x to the power of 2? Obviously x to the power of 4 because 1 over x to the power of 6 times x to the power of 4 should be giving us 1 over x to the power of 2. This you have to have a clear concept on indices. Okay, otherwise it will be a bit difficult for you. Because 1 over x to the power of 6 we are having from this term, this should get multiplied with x to the power of 4 only then can we have 1 over x to the power of 2. But we do not have x to the power of 4 in this expansion. So we cannot take this. We come to 1 over x to the power of 4. Let me just draw this rough area. Okay. So 1 over x to the power of 4 should get multiplied with x to the power of 2 to give us 1 over x to the power of 2. So this one should get multiplied with this one. Okay. Now coming to 1 over x to the power of 2. It is having 1 over x to the power of 2. So it cannot be multiplied with any term which contains x. It should be multiplied with a constant term. So this should get multiplied with this term. Okay. And if we take this constant term, if we take this constant term, this should get multiplied with 1 over x to the power of 2, but we do not have any term which is having an x or anything in the denominator, okay, for this expansion. So we can safely exclude these. We do not have to check the multiplication of these terms with the second binomial, or rather the first binomial expansion. Okay, because these are the powers in the numerator. These are the factors of x which will be in the numerator. But we have to have 1 over x to the power of 2. Therefore, there should be one of the terms which are the two terms which are getting multiplied together, one should be having x in the denominator. Okay, but in this expansion we do not have x in the denominator, and these parts do not have x in the denominator. So we can safely disregard this part. Okay, so we have now seen which two pairs we are getting, which two pairs will be contributing to our answer. And this is the first term, this is the second term, this is the third term, and I don't have any space, but this is the fourth term. Okay, so let us first of all find the second and the third terms with the coefficient from this binomial expansion. 1 over x minus 2x raised to the power of 6. Okay. So 1 over x, I am writing it again. 1 over x minus 2x raised to the power of 6. The second term we need. So the second term. For the second term, the r value will be equal to 1 and n is equal to 6. So it is 6c1 1 over x raised to the power of 6 minus 1, that is 5, and negative 2x raised to the power of 1. 6c1 nc1 is equal to n. So 6c1 is equal to 6. 6 times 1 over x raised to the power of 5 times negative 2x is equal to 6 times negative 2 is negative 12 over x to the power of 4. Clear? This is the second term and we need the third term as well. What will be the third term? It will be 6c2 1 over x raised to the power of 6 minus 2, that is 4, and negative 2x raised to the power of 2. First of all, we have to check what is the value of 6c2. For that, we need a calculator. We can do it manually as well, but for this question and for the next question also, I would prefer to use a calculator. So, in CR, it is 6, 2 equal to 15. And 15 times this negative 2 is negative 30. Sorry, it is not negative 2, negative 2 whole square. So 15 times 4, negative 2 whole square is 4. 15 times 4 is 60. And this is 1 over x to the power of 4, and in the x to the power of 4 is in the denominator, x square is in the numerator. So it will be 60 over x square. Clear? These are the two terms from this expansion which will be contributing. And what is the first first expansion, it is x plus 1 whole to the power of 3. So, x plus 1 whole to the power of 3. And we are seeing that the second term is contributing and the fourth term is contributing. So, what will be the second term? Second term will be 3c1 x squared and 1 to the power of 1. And 3c1 is equal to 3, so it is 3x squared. And the fourth term. This is the second term, fourth term. This will be equal to 3c3. X to the power of 3 minus 3, that is 0, so it will be 1 and it will be, okay, let me write x to the power of 0 and this is 1 to the power of 3. 3c3 is equal to 1, x to the power of 0 is equal to 1 and 1 to the power of 3 is also equal to 1. So this term is a constant, it is equal to 1. Now we will be just multiplying the terms. So this one, negative 12 over x to the power of 4 should get multiplied with this. Therefore, negative 12 over x to the power of 4 times 3x squared and plus 60 over x to the power of 2 times 1. And negative 12 times 3 is equal to negative 36. So, negative 36 over x to the power of 2 plus 60 over x to the power of 2 is equal to how much? 60 minus 30 is equal to 30, and again we have to subtract 6. So, it will be 24. Okay, if you want, you can use your calculator. 60 minus 36 will be equal to 24. So, it is 24 over x squared or 24x to the power of negative 2. This is our answer. This is our answer. 24x to the power of negative 2. And mind you, this is our answer. I am saying this is the term. But the question is asking us to give the coefficient. This you have to be careful about. If the question asks you to give the entire term, so then this will be the answer. But I am showing you the question. We are saying find the coefficient of x to the power of negative. So, we cannot include x to the power of negative. So, therefore, for this question, since they are asking about the coefficient, our final answer will be this. 24. If they ask for the term, you give this as your answer. If they ask for the coefficient, you give this as your answer. Okay. So, let us move on to the next question. Now, the second question says find the coefficient. Again, the coefficient of x to the power of 2. Previous question contained x to the power of negative 2 and this one is x to the power of positive 2. In the expansion of 2x plus 1 over x to the power of 3 times x squared minus 2 over x to the power of 4. Now, in this question, you see you are having two binomial expansions getting multiplied together and each of them is containing two terms and both the terms contain x. Okay. But you don't have to be worried or tensed. The method will be exactly the same. So, doesn't matter whether x is present in both the terms or is present in one of the terms. Okay. Let us start with our answer. So, okay, because both the expansions containing x, let us start from the very first one. 2x plus 1 over x to the power of 3. So, 2x plus 1 over x to the power of 3. We will be writing only the powers of x for individual terms. Okay. So, we start with the first term. It is x to the power of 3. Second one, x to the power of 2 times 1 over x. Next, x to the power of 1 times 1 over x to the power of 2 or x squared. And finally, it is 1 over x to the power of 3. There are 4 terms. So, we simplify them. The first term is x to the power of 3. Second term is x. Third term is 1 over x. And fourth term is 1 over x to the power of 3. Next, we take up this one. X squared minus 2 over x to the power of 4. Obviously, it will be containing 5 terms. So, let us write the powers of x. It starts with x squared. This is important. You don't take only x. You have to take x squared. X squared raised to the power of 4. Next one is x squared raised to the power of 3 times 1 over x. Third one, x squared raised to the power of 2, 1 over x squared. X squared raised to the power of 1, 1 over x to the power of 3. And finally, it is 1 over x to the power of 4. So, you have 1, 2, 3, 4, 5. 5 terms. Now, we simplify these 5 terms. X to the power of 2 whole raised to the power of 4 is x to the power of 8. X to the power of 2 whole raised to the power of 3 is x to the power of 6 and divided by x. So, it is x to the power of 6 minus 1 is 5. This is x to the power of 4 and divided by x squared. So, it is x to the power of 2. This one is x squared and 1 over x to the power of 3. So, it is 1 over x. And finally, you have 1 over x to the power of 4. So, now let us try to pair the terms. We first of all take the first term of this expansion. It is x to the power of 3. In order to get x to the power of 2, we have to get this term divided by x. So, obviously, this should get paired with this one. Okay. So, we have found the first pair. This is x. Therefore, it should get multiplied with another x, but we don't have another x in this expansion. So, this does not contribute. This is 1 over x, so we should multiply this one with x to the power of 3, otherwise it will not be contributing. we do not have x to the power of 3 over here. So we leave this. Coming to 1 over x to the power of 3. If this one gets multiplied with x to the power of 5, it will be giving us a product of x to the power of 2. And we are having this x to the power of 5 over here. Okay. So now we have got the two pairs. This is the first term. This is the fourth term. And this is the second term. And this is the fourth term. Okay. So now that we know the term numbers, it is very easy to get the coefficients and the entire term. Okay. So 2x, first of all, I take this 2x plus 1 over x raised to the power of 3. And we will be taking the first term. Is equal to 3c0. And 2x raised to the power of 3. So 3c0 is 1 and 2x raised to the power of 3 is 8x cubed. And we need the fourth term. So this is the first term and the fourth term. Fourth term, last term. So it will be 3c3 and 2x to the power of 3 minus 3, of course. And this is 1 over x raised to the power of 3. 3c3 is equal to 1, 2x raised to the power of 0 is 1, and this is equal to 1 over x to the power of 3. Okay. Now coming to this expansion. So this is x square minus 2 over x whole raised to the power of 4. And we need the second and the fourth terms. So second. It will be 4c1. For the second term, r value is equal to 1. And x square raised to the power of 4 minus 1, that is 3. And negative 2 over x raised to the power of 1. And 4c1 is 4 times negative 2 is equal to negative 8. And x to the power of 2 whole raised to the power of 3 is x to the power of 6 divided by x is x to the power of 5. And we need the fourth term. So fourth term means the second last term. So it will be 4c3 x square raised to the power of 4 minus 3, that is 1, and negative 2 over x raised to the power of 3. 4c3 is equal to 1. N minus 1 is equal to, equal to 4. 4c3 is equal to 4. And negative 2 raised to the power of 3 is negative 8. So negative 8 times 4 is equal to negative 32. This is x square and this is x to the power of 3. So it will be 32 over x. Okay. So these two will be getting paired. And these two will be getting paired. Okay. So 8x cubed times negative 32 over x plus 1 over x cubed times negative 8x to the power of 5. And now if you are not being able to understand why am I putting this plus sign in between, I have explained all these things in detail. You just watch my video sequentially. Okay. I hope you will not be facing major difficulties in solving the past paper questions. Okay. So now 8 times 32. It is 8 times 2 is 16 and 8 times 3 is 24 plus 1 is 25 and there will be this negative sign in front. So it is negative 256 x to the power of 2 and this one is negative 8 x to the power of 2. So we are having a negative coefficient 256 and 8 is equal to 264. So it is negative 264 x to the power of 2. And this negative 264 is our answer. This part is our answer because they have asked for the coefficient. Had they asked for the whole term, our answer would have been negative 264 x to the power of 2. Okay. So students, this brings us to the end of this session. In our coming session, we will be seeing questions where we will be asked to find the power of the binomial expansion. So I am taking up every type of question which comes in your board examination or in your school examinations. So please stay tuned. Please watch my videos regularly and stay tuned till the end. Okay? So we meet again very soon in our next video session. Thank you for watching this video till the end. Please like, share, subscribe and comment if you find the video helpful. So bye for now.